What's up, Raiders? Just want to continue our discussion about trigonometry basics in our Odyssey Ware unit here for geometry. And the last couple of videos, we've worked with the calculator here, and anytime we've done anything with trigonometry, we've used the sine, cosine, tangent buttons smack dab in the middle of the calculator, and any calculator that has these buttons pretty much has them in the same spot. But let's say you're doing some trigonometry work and you do not have access to a calculator. What do? Well, you've got a couple options. You can just go right to Google, and just like on the calculator, you could type in sine of 30 degrees and get, which we should already know from previous videos, sine of 30 is 0.5. You could do the same thing in Google. You can go to Google search and don't just do sine of 30, do sine of 30 and actually write degrees, and it'll give you the answer. And then from there, it'll pull up a calculator that you can just access for free to do any basic sine, cosine, or tangent calculations, no problem. And another option, old school way to do it, is these trigonometry ratio tables. And it's pretty disorienting to look at the entire table because it's a whole host of numbers. And this is what's in Odyssey Ware, but it's not as bad as it looks. It's set up with columns for sine, cosine, and tangent, just like you have sine, cosine, and tangent on the calculator. And then it's just numbered. One column is 1 through 45 degrees, and the second column is 46 through 90 degrees. So for example, we already know sine of 30 degrees is 0.5, but if you wanted to look that up on the table, you'd find a column with sine, and then just go down until you get to 30 degrees, and it's 0.5, which again, we already know that it would be. Now, notice I've also got highlighted over in this other column here, for cosine of 60 degrees is also 0.5. So that's no coincidence that the sine of 30 degrees equals the cosine of 60 degrees. So we'll take a little closer look at why that is. So let's set up a triangle here. Right, triangle. So here's 30 degrees, and then we know the interior angles of a triangle have to add up to 180. So if this is 30 and this is 90, this one has to be 60 degrees. So we've already talked about the fact that sine of any angle, so I'll do sine of theta, sine of any angle, that's really just a shortcut way of saying, okay, take the length of the opposite side and divide it by the length of the hypotenuse. That's all sine is a shortcut way of saying. So in this case, relative to the 30-degree angle, the opposite side is right here, and the hypotenuse is right here. So sine of 30 degrees works out to be 0.5. Well, again, that's just based on the characteristics of a 30, 60, 90 triangle. The side opposite 30-degree angle is always half of the hypotenuse. So if this side length here is 8, then the hypotenuse would be 16. Again, this side length is half of the hypotenuse. Well, if we look at this from the perspective of a 60-degree angle, so I'll recreate the same triangle. Now, when we're focusing on the 60-degree angle here, and we'll do a different trig function of cosine, the cosine of any angle, again, cosine is just a shortcut way of saying take the length of the adjacent side to the angle you're focusing on. Again, adjacent just means next to, divided by the hypotenuse. So let's look at the same triangle from the perspective of the 60-degree angle. Well, from the perspective of the 60-degree angle, this is the adjacent side, and this is the hypotenuse. So notice, whether we look at it from the perspective of the 30-degree angle, or the opposite side and the hypotenuse, here for sine, or look at it from the perspective of the 60-degree angle, which would focus on the adjacent side to that angle and the hypotenuse, we're still dealing with the exact same combination of sides. So cosine of 60 degrees would be the adjacent side length over the hypotenuse, 8 over 16, which again is 0.5. So it looks like it's a coincidence that sine of 30 degrees equals the cosine of 60 degrees, but really it's just two different ways of saying, hey, we're gonna look at the exact same two side lengths here. All right, take care, Raiders.